So, good afternoon, students. And today we will continue with the chapter which we were discussing earlier, that is motion. And we were with the portion of that is a graphical representation of the motion. And in the graphical representation of the motion, we were discussing the distance time graph. We were discussing distance time graph. And in the distance time graph, we discussed case one. Case one, once again, I am recapitulating. Case one, when we discussed when the body is at rest. Case two, we discussed when the body is in uniform motion. And case three, we were discussing case three. Okay, we were discussing case three. So students, today, now we will be discussing the case three, that is when the body is in non-uniform or accelerated motion. Okay, so here what we will be first doing. Now, case three, that is when the body is in non-uniform motion or the accelerated motion. Before going into the discussion of that, what type of the graph we will get when the body is in non-uniform or the accelerated motion, let me ask you one question. That is, what is a non-uniform motion? Okay, before going into the non-uniform motion, first let me ask to you, what do you mean by uniform motion? What do you mean by uniform motion? Okay, just wait, let one by one. Okay. Yes, I've seen your hands. Okay. Okay. Just a moment. My question, yes. Yes, Sagar plus yes, Sagar. Yes, you can unmute yourself, Sagar.
Yes, sir.
Yes, Sagar. What is uniform motion?
What is uniform motion? When an object covers equal distance in equal interval of time.
Okay, fine. Okay, good, Sagar. So you can.
Good, Sagar. So you can.
Now, after this, okay, Mehak Kumari, you can unmute yourself, Mehak. 9B, you can unmute yourself, Mehak.
Yes, sir.
Yes, Mehak, what do you mean by uniform motion?
Sir, uniform motion cover equal distance at a equal interval of time.
Very good, Mehak. Correct. Okay, you can mute yourself. Very correct. That is when the body cover equal distance in equal interval of time. Correct. So now students, you see, as you have told that when the body cover equal distance in equal interval of time, it is called uniform motion. And now we are going to talk about that when the body is in non-uniform motion. So first we have to define what is a non-uniform motion. A non-uniform motion, definitely when the body cover unequal distance in equal interval of time. So suppose, see here, suppose a body is dropped and it falls freely under the action of gravity. We all know that when a body is being dropped, its motion get accelerated. Why its motion get accelerated? Because it is under the attraction force of the gravity. So the distance traveled by the body in successive seconds goes on increasing. Now from this table, first of all of you see, there are two parameters, time and distance. There are two parameters, time and distance, and with the progress of the time, you see time 0 second, 1 second, 2 second, 3, 4, 5. At 0 second, distance cover is 0 meter. After 1 second, the distance cover is 5 meter. After 2 seconds, the distance cover is 20 meter. After 3 seconds, the distance covered is 45 meter. After 4 seconds, the distance covered is 80 meter. And after 5 seconds, the distance covered is a 125 meter. So what happened? When we will plot, like you see this graph. Now on the y-axis, we are taking the distance, and on the x-axis, we are taking the time. Now with the progress of the time, 1 second, 2 seconds, when we are plotting the motion we are getting is a curved line. Okay, it is a curved line. These points indicates the distance which are covered in suppose 2 seconds, the distance which are covered like in 3 seconds, then in 60 seconds, and so on like this. Okay, so whenever we will plot this, and we will also, so when we actually plot this point, taking time along the x-axis and distance along y-axis, and join these points, we obtain a curve. And the distance time graph in this case is a curved line, indicating that the motion is non-uniform, or it okay. So students, we were discussing the case 3, that is when the body is in non-uniform motion or the accelerated motion. So for this, the different values of the time and the distance is given. And we were discussing that when we actually plot these points, taking time along x-axis and distance along y-axis, and join these points, we obtain a curve which is shown in the figure. As I discussed with you, we will get a curved line. Note that the distance time graph in this case is a curved line, indicating that the motion is non-uniform. And we observe that the slope of the distance at any point. And so normally what will happen when we will plot this graph, we will get a curved line. But remember students, there is a point to be remembered over here, that when the motion is retarded, okay, when the motion is retarded, that is the body has negative acceleration, the slope of the distance time graph is reversed. Okay, the slope of the distance time graph is reversed as shown in the figure. For the sake of comparison, we have redrawn the distance time graph for the positive acceleration, where I'm showing you this, that where it happened. You see over here, student, all of you focus on this graph. All of you focus on this graph, which is there in figure 1.12. See, this is a very important one. See, on y-axis, when the distance is plotted, on the x-axis, when the time is plotted. For negative acceleration, we have the curved line. Just a moment. For negative acceleration, let me use the. For negative acceleration, we have this line, this part. Okay. For positive acceleration, the curved line goes up, and the acceleration is 0. Acceleration is 0. That means the body is moving uniformly. It is a straight line. It is a curved line for the positive acceleration, and the line or the slope bends downward for the negative acceleration. Now, is it clear, student? This graph is clear to all? this graph is clear to all? Okay. Okay. Okay, fine. Okay. Yes, I've got the feedback. Okay, fine. So now students, okay, Shripati, huh? Okay. Okay, Shripati, I'm once again going to explain this graph. Students, we were discussing the distance time graph for the three cases. The first case we discussed when the body is in uniform motion. The second case we discussed when the body is in first case we discussed when the body is at rest. The second case we discussed when the body is in uniform motion. And the third case we are discussing when the body is in non-uniform motion. As from the table, as from this table, you can very well understand that why we are calling this as a non-uniform motion or uniformly accelerated motion, because of the fact that with the time interval, the distance covered is changing not in a uniform manner, or we can say non-uniformly. As you can see, with the 0 second, the distance covered is 0. With the progress of 1 second, again the distance covered is 5 meter. With the progress in 2 seconds, the distance covered is 20 meter. With the progress in 3 minutes, the distance covered is 45. 3 seconds, the distance covered is 45 meter. So you can very well see that the distance is increasing in a non-uniform manner, and that is why it is called the non-uniform motion or the accelerated motion. So when we are plotting this distance on the y-axis and time on the x-axis, then what we will get? We are getting a curved line. Okay, we are getting a curved line. Got it? So this is a positive acceleration. Why it is said to be a positive acceleration? Because the velocity is going, or we can say the speed is increasing under the force of the gravity. The speed is going on increasing. So for our simplicity, this graph has been shown in figure 1.12, where the three different situations are plotted. And what are the three different situations? One is the positive acceleration, which on the upper part we have seen, where we are getting a curved line. When the acceleration is 0, that is when the body is moving in a uniform motion, then it is definitely a straight line passing through the origin. On the other hand, when it is a negative acceleration, that is a retardation, then the slope, or we can say the graph, is in this form. Got it? Is it clear, Shripati, now? Shripati, is it clear to you now?